looked at scatter diagrams previously, we've been able to make a judgment as to whether it has a positive or negative correlation based on how closely the points resemble a straight line. We then go on to draw a line of best fit. However, at A level, we are given the means to actually provide a measurement as to how strong the correlation is, either negative or positive. In addition, there is a regression line replacing the line of best fit. One such measure that is used at A level is the product moment correlation coefficient, and it is calculated using this formula. Fortunately, we do not need to use this formula in the exam. We will be using our calculator solely to calculate anything to do with the product moment correlation coefficient. Note that it is also often given the symbol R. The value of the product moment correlation coefficient, or PMCC, will give you a value between -1 and 1. 1 would indicate a perfect positive correlation, and -1 would give you a perfect negative correlation. Typically, we would consider anything between 0.5 and 1 as a positive correlation, and anything between -0.5 and -1 as a negative correlation. The values around 0 are considered as no correlation or a very weak correlation. So in this example, we've got moisture content m grams of water per 100 grams of dried solids of core samples of mud from an estuary being measured at various depths d meters. And the results are displayed in the table below. Question asks us to calculate the product moment correlation coefficient R and comment on the result. So this is where you need to get your calculator at the ready. So on the ClassWiz calculator, take yourself to the statistics menu. And this particular one, we want number 2, which is y equals a plus bx. That will be for linear data. And now you can see we have x and y columns in our table. And we enter in the values as so. Once you finish putting the x values in, make sure you put in the matching y values. Okay, once you've done that, you press the button marked OPTN or option, and we want number 4 for regression calculation. Once you're taken to that, you're taken to some summary values. The number that we are interested in at the moment is the R value. And the R value is minus 0.952 to 3 significant figures. So that R value of minus 0.952, that is very close to -1. So that indicates a strong negative correlation. And because it is a strong negative correlation, this particular value for the PMCC indicates a linear model is therefore appropriate. So fairly straightforward so far. In the next example, we have the height and foot length for 8 women. And again, it goes on to calculate the product moment correlation coefficient R and comment on the result. So we will go back to our table of data. We will look to delete all. And enter in the data that we have. Calculate exactly the same way, press the option button, number 4 for regression, and again we are interested in the R value. And to 3 significant figures we have 0.899. This particular value is very close to 1. So a strong positive correlation is indicated. And again, as it is a strong positive correlation for a PMCC, a linear model is appropriate. In this final example, we have a biologist comparing the intervals between mating calls of certain species of tree frog and the surrounding temperature. And those results were obtained in the table below. The data was then coded using y equals log m and x equals log t. Part A says complete a table showing the coded values of log m and log t, correct to 3 decimal places. Part B, calculate the product moment correlation coefficient for the coded data. And part C, comment on the answer and suggest a suitable model for the data. Calculate the log values using the log button on your calculator, using base 10. And make sure you are using each 1, 2, 3 decimal places. Okay, so now the table is complete. We can move on to part B. Part B asks us to calculate the product moment correlation coefficient for the coded data. So we take ourselves back to our statistics mode and we enter in the values as we see them to 3 decimal places. Once those 6 pairs of values are entered in, press the option button, number 4 for regression, and we have an R value of minus 0.943 to 3 significant figures. Now for part C, it's comment on the answer and suggest a suitable model for the data. Well, we can clearly see that we have a number close to -1, so this is a strong negative correlation. And then suggest a suitable model for the data. Well, we need to consider that this data was originally coded using log m and log t. And bringing back the knowledge that we have from the previous lesson, we can go on further to say the strong negative correlation is between log t and log m. Therefore, the model that is suitable would be m equals a t to the n.